Welcome, everyone. We're going to present some information about Scott Swamp and Maria Road. And my name is Mary Ridings Ward. I'm the president of the Pequabic River Watershed Association, and I'm going to tell you more about the Pequabic River Watershed Association tonight. So I'm going to talk to you about the Pequabic River Watershed Association, the watershed approach to clean water and stormwater management, the Scott Swamp property, and give you a list of resources. So the Pequabic River Watershed Association has a mission to protect and restore water quality, supporting a healthy and diverse watershed ecosystem. We do that through education, outreach, advocacy, and special projects. And you can see some of those items pictured here, like the invasive species removal, which saves the white pine stand in a wetland area of Bristol. We've cleaned more than 30 tons of trash from the river. We do citizen scientist work to survey for macroinvertebrates, stock fish, restore habitat, and we built a rain garden at Bristol Eastern High School, a great bioinfiltration project. So what is the Pequabic River Watershed? The watershed is a land area of about 58 square miles. It is in 7 different towns. We have 3 sub-regional basins and 32 local basins. The Pequabic River itself is 19 miles long. It begins just over the Harwinton border in Plymouth. And I'm gonna have to do some pointing with my hands tonight because I love maps. And so I'll just show you that the Pequabic River begins just over the line in Harwinton. It comes down through Plymouth into the Terryville section of Plymouth, where it turns east and flows through Bristol into the Forestville section of Bristol, into Plainville, where it turns north and goes up into Farmington and empties into the Farmington River right at the juncture where the Farmington River has turned north. Okay. The nooks and crannies. So a watershed is like a Thomas's English muffin with lots of nooks and crannies. So as you saw on the previous slide, there's an outline of the 58 square miles that encompasses the Pequabic River watershed, and we are just a cranny inside the Farmington River watershed. So the Pequabic River watershed is the southernmost basin of the Farmington River watershed. And here you can get a perspective that the Farmington River watershed actually begins up in Massachusetts and comes down into Connecticut. And what you can see here is where the Farmington turns north. It also then turns east and empties into the Connecticut River. So that gives you a perspective of the Farmington River watershed. And now we can take a look at another perspective, that the Farmington River watershed is nested inside the Connecticut River watershed. So you might say that that's kind of our whole Thomas's English muffin, because that empties into the ocean. So here we have a view of the Connecticut River watershed. And why are we concerned about water? Well, it is a finite resource, so it's very valuable. All the water in the world is all the water there is, and it is the one element that takes the form of liquid, gas, and a solid. Here's a quick image of the water cycle. And what is the watershed approach? The watershed approach is a coordinating framework to improve water quality. It is based on topography and geography, right? The nooks and crannies, not political boundaries. The watershed approach involves all stakeholders, is community-based, and employs collaborative partnerships. We use the watershed approach to determine a prioritization of efforts and identify science-driven actions with environmental and public health objectives. So the watershed-based plan is used to develop a plan for clean water to reduce the water body impairments from non-point source pollution. And those non-point source pollutants are identified as nitrogen, phosphorus, bacteria, and sediment. We know that we have a lot of other chemical and mineral contaminants and metals in our water. But the watershed-based plan has identified these non-point source contaminants as being primary pollutants. So the EPA provided a 9-point template for watershed associations to develop a plan to clean the water in their watershed. The Pequabic River Watershed-Based Plan and the Farmington River Watershed-Based Plan have been approved by DEEP and accepted and on file with EPA. So on a few of the slides, I've listed resources so that if you're interested, you can go back and find some of these documents that I'm referring to. So when we want to clean the water, we're very interested in stormwater. Stormwater picks up these contaminants and carries them into our fresh water. And we can infiltrate the stormwater either with the soil and biomaterials, and sometimes we infiltrate the stormwater with man-made materials. But we want to infiltrate the stormwater to clean it. And when we do that, it greatly reduces the cost to clean water. It also reduces the maintenance costs on stormwater systems when it gets infiltrated through the soil, lowering capital costs. When we infiltrate stormwater, we're reducing the volume in our ponds and lakes and rivers and streams. We provide stream channel protection, groundwater recharge, thermal regulation, and it reduces and attenuates flooding. And because it minimizes the pollutants that get into our water, it creates safer recreation on and in the water. So infiltration is really key to the work that we do to clean the water. Here's a map of the Pequabic River watershed, identifying the subregional basins. The purple over on the west side is the Poland River. And that area has a lot of forest. That's our cleanest subregional basin. And then the green subregional basin is the Coppermine Brook Basin. And that starts out really clean up in Burlington. And then it gets fairly contaminated as it meanders down into Bristol through the suburban and urban areas with a lot of impervious surface. The pink area on the map is the Pequabic River main stem basin, and that has the most impervious surface, the least amount of forested land, and is our dirtiest section. You can see Scott Swamp in Farmington, right over here, and you can see the different towns: Burlington, Harwinton, Plymouth, Bristol, little piece of Wolcott, Plainville, and once again Farmington. So that's a map of our 58 square miles and our 3 sub-regional basins. So we know that land use is the primary determinant of water quality. And the Poland River sub-regional basin is 73% forested. In contrast, the Pequabic River sub-regional basin is only 30% forested. So now when we take a look at the contaminants that are modeled to be existing in each of those sub-regional basins, we can see that the Pequabic River sub-regional basin has the highest quantity of phosphorus, denoted by the blue bar, total suspended solids, denoted by the orange bar, and total nitrogen, denoted by the green bar. Whereas the Poland River, which is 73% forested land cover, has the least amount of pollutants. So land use is the primary determinant of clean water, of water quality. Now we're looking at Scott Swamp, which is a local basin. And the Scott Swamp Brook has its headwaters empty into and pass through Scott Swamp, exiting the swamp east of Cope Farms Road and flowing south into Bryant Pond and continuing southeast, crossing under Route 6 behind Tunxus Community College and meandering nearly a mile further before emptying into the Pequabic River. The basin encompasses 3.1 square miles of land. And this map came from CT Eco, which is a Yukon site, and they have great maps and information for decision makers at the municipal level. So the Maria Road property and Scott Swamp. There's 88 acres in Farmington and 30 acres in Bristol. It provides a wildlife corridor from Lake Garda in Burlington through the swamp and north to Farmington Forest to Farmington River and going south to Shade Swamp and the Pequabic River. So a wildlife corridor and connectivity. And we're concerned about a wildlife corridor because some animals will interact more with humans. So when we want clean water, it is for drinking, but we also have to have clean water for the animals to take care of the ecosystem for us. And we're going to talk a little bit more about those interactions between animals and humans. So the development proposal is to clear 22 acres of forested land adjacent to the swamp. And that will have some negative impacts on wildlife in the swamp, being reduced habitat and reduced water quality. Stormwater wetlands, the value. They promote slowing flow rates, utilize natural processes for nutrient sequestration and bacteria control, increase habitat and biodiversity, which is very important for human health, and used on a large scale, they can meet low-impact development regulations. And so what's the plan for Scott Swamp? Well, the town of Farmington has an environmental resource inventory and plan. And we'll talk a little bit about how they address Scott Swamp. And the Farmington Valley Biodiversity Project has a report that talks about the value of Scott Swamp. And the Town of Farmington Plan of Conservation and Development refers to Scott Swamp. So the Environmental Resource Inventory and Plan for the Town of Farmington says that Scott Swamp is regionally significant. The Scott Swamp Brook watershed and its associated wetlands provide important functions and values on both a regional and local scale. The most significant are groundwater recharge, flood flow alteration, and wildlife habitat. The plan also identifies that Scott Swamp is a critical and unique wetland system and critical wildlife habitat. The Farmington Valley Biodiversity Project is an example of the regional significance. So I'm going to talk a little bit more about this project, but right now you can see that they included the towns of Suffield, East Granby, Canton, Simsbury, Avon, and Farmington. And so this map shows integrating wetlands, and you can see in Farmington, down here is the Scott Swamp local basin. Okay. So the green area on this map is wetlands. And so the Farmington Valley Biodiversity Project, put together by the Metropolitan Conservation Alliance, is a collaboration of 7 contiguous towns within the Farmington River Valley. And their objectives were to collect and map comprehensive data on biological resources, identify and map priority conservation areas, and promote awareness of the region's unique ecological communities, the importance of biodiversity, threats to biodiversity, and the role that various municipal commissions can take toward the conservation of biodiversity. So they undertook this project referring to a statement by Miller and Clemens, who are wetland and vernal pool experts. And what that statement is right there at the top of this slide with a conceptual template to guide development patterns. It may be possible to maintain biodiversity and ecological health. Without this template to guide us, loss of biodiversity is certain. And the report goes on to note, although careful planning can mitigate some of the adverse impacts of such development, most planning occurs on a site-specific scale and does not consider the much larger landscape scale picture. Ironically, the land review process currently practiced by most municipalities may actually foster fragmentation by considering too small an area in the review process. The transitions that are occurring within our landscape today are much more permanent than past changes, and they do not accommodate our native biodiversity. I think those are important quotes from this report. And fragmentation. The municipal land review process may foster fragmentation, according to the Farmington Valley Biodiversity Project, by considering too small an area in the review process. And the few wildlife species that have adapted to such changes that fragmentation provides are opportunistic and/or invasive species, which thrive at the expense of a more diverse and balanced biological community. Fragmentation and development. So there's more information from the Farmington Valley Biodiversity Project that I thought was very helpful. And they talk about impervious surface, which degrades the natural habitat by altering hydrologic conditions, which impacts water quality, and introduces the edge effect, which degrades terrestrial habitat. The impervious surface and fragmentation create a loss of biodiversity, which increases invasive species and pests. So we're tying together here the fragmentation, the impervious surface of development, and finding that it all decreases biodiversity. And when you decrease biodiversity, you increase invasive species, which includes pests as well as plants, and these often harm humans. For example, there's an increase in Lyme tick due to a missing link in the food chain when you don't have enough wetlands and diversity. And you have a question?
Yes, would you be able to define impervious surface and fragmentation?
Okay, great. Thank you for asking that. Yes. So impervious surface is that which does not allow water to flow through it. So roofs, sidewalks, streets, driveways, those are all impervious surfaces. And fragmentation. And fragmentation is simply chopping something up, right? And so if we have a forested land that is 100 acres, we know that that provides a particular habitat for different species. Fragmentation reduces the opportunity for range for certain animals, and that can be problematic because those animals might then start coming to humans' homes and looking for their food, looking for a handout of food from the humans. And more on fragmentation, because this is an important concept, and it does go to the idea that a watershed does not have political boundaries. If we want to keep the water clean within a certain ridge line, those nooks and crannies, we're not just going to stop at a town border or a state border. And because we're making permanent changes to our landscape, it is imperative to carefully identify where the matrix of wildlife habitats and corridors occur. So here again, Miller and Clemens advocating for plans. It is not sufficient to randomly protect small parcels or island habitats across the region in the hope that they will provide viable wildlife habitat. Instead, we must discover where species and natural communities already occur and use the results of those inquiries as a template for making future land use decisions. If we apply this conceptual template to guide development patterns, it may be possible to maintain biodiversity and ecological health. Without this template to guide us, loss of biodiversity is certain. So the Farmington Biodiversity Project did prioritize areas for conservation, and this is the town of Farmington with the priority areas listed in pink. So this is Maria Road, extending over to the town forest that's been identified as a priority area. Here's Shade Swamp, okay? So this is what the multi-town project on biodiversity identified as priority conservation areas for Farmington.
Could you stop a moment and tell us what are those little dots, colored dots we see on the map? I see it's like dark purple inside of light purple, and then there's maybe some green in certain locations.
Yes, I can identify for you what those dots are. And it depends on the color, but they were looking at imperiled species, imperiled communities, Category 1 focal species, potential vernal pool. So that's what the dots represent. So it was a biodiversity study, and they identified priority areas based on where some of these species exist. So now moving on to the Farmington Plan of Conservation and Development, they talk about Scott Swamp and the flood attenuation properties. And they also say that the Scott Swamp drainage basin is an important town asset. They describe it as an extensive network of wetlands located north of Morea Road along the Farmington-Bristol border and forming the headwaters of Scott Swamp Brook. And they also identify that flooding along the boundaries of this brook is infrequent. The Farmington Plan of Conservation and Development has also targeted Scott Swamp Brook for water quality upgrade. And the Farmington Acquisition Committee and the Farmington Valley Biodiversity Project have targeted the Scott Swamp Brook for conservation. And I've listed here some information from the Plan of Conservation and Development to further identify the target for water quality upgrade. So they're going to be working with DEEP, because DEEP has set a goal of achieving Class A water quality in the Scott Swamp Brook. And they're talking about discharges into the Scott Swamp Brook that are a result of past improper spills, discharges, or storage of industrial chemicals in the vicinity, with DEEP's goal to clean up these contaminated areas. So that would be Scott Swamp Brook in the industrial area, right, closer to the Plainville border, because the brook has its headwaters at the swamp, but then it flows south down into the Pequabic River, going past Tungus Community College and into Plainville. So I've listed here for you some of the resources and how you access them. So resources from my talk today included the Town of Farmington Plan of Conservation and Development, which you can find on the Town of Farmington Planning and Zoning webpage. You'll also find on that page the environmental resource inventory and plan. And on the Town of Farmington Land Acquisition Committee webpage, you'll find the land acquisition list and land acquisition planning map. The Farmington Valley Biodiversity Project, you would Google to find that, as well as you can Google to get to CT Eco, although on a previous slide I did provide the full URL web address. And Clear at Yukon has a lot of information for municipal decision makers. And the Town of Farmington Department of Engineering webpage has many documents on stormwater. Some great information out there. And I also think it's important to understand that there is grant funding available to conserve and protect property through the Connecticut Department of Energy and Environmental Protection, Open Space and Watershed Land Acquisition Grant Program, and through the U.S. Fish and Wildlife Service, North American Wetlands Conservation Act grant. So those are two of the primary sources to get funding. So the resources and the grant funding wraps up my talk, and then I wanted to make mention for those who are interested that there is a public hearing on Maria Road development proposal on February 13th at 7 o'clock. And I also wanted to say, as a future step for Connecticut, there's a proposal for a Connecticut Environmental Rights Amendment. And the CT Environmental Rights Amendment will require government officials to put environmental protection first at the start of planning, decision-making, legislating, and regulating industry, development, and the transition to renewable energy. So the CT Environmental Rights Amendment will require planners to avoid and prevent environmental harm, not simply manage it after the fact. So what we're working with are the regulations that get enforced by our inland wetlands and our planning and zoning commissions versus some of these plans that have been put in place. But the real question often is, how do the plans get implemented? So I think that's important information for all of us as citizens to consider. And if you're concerned about ecology, the environment, biodiversity, there's a lot of resources that can help you to get better informed. So that's the conclusion of my talk. And if you'd like to get a link to this presentation that is being taped for Nutmeg TV, please be sure to sign up. In the back, there's a sign-up list, and we'll email you a link to the YouTube presentation so that you can look at it, get any other information that you'd like off of the slides. So that's available if you sign up. And thank you for being interested in the environment and learning a little bit about the Pequabic River watershed. Thank you for coming.